The star older than the universe, a cosmic mystery. For centuries, humanity has gazed at the stars, seeking answers about our origins, the nature of time, and the structure of the cosmos. And while science has made remarkable progress in understanding the universe, some of the most fundamental questions remain unanswered. How did everything begin? How is the universe evolving? And, perhaps most intriguingly, how old is it, really? In recent years, these mysteries have only deepened. In 2023, NASA's James Webb Space Telescope, a marvel of modern engineering, detected celestial objects so ancient, so distant, that they appear to challenge everything we thought we knew. Among them are stars and galaxies that seem older than the universe itself. How could a star exist for a longer period than the universe it resides in? Is our current model of cosmic history flawed? In this video, we'll explore one of the most astonishing astronomical discoveries and the questions it raises about the nature of space, time, and existence itself. Let's begin by traveling roughly 200 light-years from Earth to a fascinating star located in the constellation Libra. Known as HD 140,283, but more famously nicknamed Methuselah, this star has captivated astronomers for decades. Named after the biblical figure who reportedly lived for 969 years, Methuselah has earned its title by being one of the oldest stars ever observed. What makes Methuselah so interesting isn't just its age. The star travels at a high velocity, about 44.8 kilometers per second, indicating a dynamic and possibly chaotic history. It is believed that the star originated in a smaller dwarf galaxy that later collided with and merged into the Milky Way. But this fascinating past is only a small part of the puzzle. The most controversial feature of this star is its age. Early calculations placed it at around 16 billion years old, far older than the estimated age of the universe, which is approximately 13.8 billion years. Even after refined measurements, the star's estimated age came to about 14.46 billion years, with a margin of error of ±0.8 billion years. This still places it right on the edge, or even beyond, the supposed age of the universe. This has led to a profound paradox. If the universe is 13.8 billion years old, how can a star be older than that? Could the measurements be flawed? Or have we misunderstood the very age of the universe? To grasp this issue, we need to understand how scientists determine the age of stars. It's a complex process. Unlike living organisms, stars don't leave behind fossils or historical records. Astronomers estimate a star's age by observing its color, brightness, chemical composition, and especially its rotation rate, a method called gyrochronology. As stars age, their rotation gradually slows down, and by comparing this slowdown to stellar models, scientists can estimate how old they are. Methuselah is one of the few stars whose age can be calculated with relative accuracy using these methods. Its surprising result has prompted scientists. Could the universe be older than we currently think? To visualize this, imagine compressing the entire history of the universe into a single year. The Big Bang would happen on January 1st. Earth wouldn't appear until late December, and all of recorded human history would take place in just the final seconds of December 31st. In this scale, even a small discrepancy of a few 100 million years is enormous. So how do we currently estimate the age of the universe? One key method involves observing the cosmic microwave background, the faint afterglow of the Big Bang. Another approach involves studying distant galaxies and analyzing how fast they are moving away from us. This movement causes a phenomenon known as redshift, the stretching of light due to the expansion of space. By measuring redshift, astronomers estimate how fast the universe has expanded, which leads to the 13.8 billion year estimate. But what if redshift isn't telling the full story? That's when new and bold theories come into play. One such idea has been proposed by Professor Rajendra Gupta from the University of Ottawa. He suggests that our interpretation of redshift might be incomplete. Instead of redshift being solely caused by the expansion of space, he proposes that protons, the building blocks of atoms, may lose energy over vast cosmic distances and timescales. This slow energy loss, combined with expansion, could be responsible for the redshift we observe. If Gupta's theory holds true, it could mean that the universe is not 13.8 billion years old but as old as 26.7 billion years, almost twice the currently accepted age. Such a revision would not only explain stars like Methuselah but would dramatically reshape our understanding of the cosmos. It would suggest a much older universe, one with a far more complex and extended history than we ever imagined. This idea is still highly speculative and debated, but it opens the door to fascinating possibilities. Could there be forces, particles, or physical principles we have yet to discover? Are our current models missing a deeper layer of reality? For now, the star known as Methuselah remains a cosmic enigma, a glowing reminder that the universe still holds secrets we have only begun to uncover. Whether it's a measurement error, a gap in our understanding, or a sign that our universe is far older than we thought, one thing is certain: the cosmos continues to challenge and inspire us. And as we develop more powerful telescopes and deeper theories, we may one day solve the mystery of the star that